Let's go to our second problem. Again, we want to set it equal to 0. So if we move the 7 minus 10x to the left-hand side and write it in descending powers, we would get 2x cubed minus 5x squared plus 10x minus 7 is less than 0. Now that I have it set to 0, this tells us I'm looking for where our function values are negative. We do not want where they equal 0, just where they're negative. Well, we have a polynomial, but it's not a quadratic, so we can't necessarily factor it right away. But we can use all of our previous knowledge, including the rational zero theorem, find factors of our last term, which would be plus and minus 1 and plus and minus 7. It's nice, they gave us a prime number. And factors of the first coefficient, which would be plus and minus 1, plus and minus 2. So our possible rational zeros would be plus or minus 1 over 1, which is 1, plus or minus 1 over 2, which is 1/2, plus or minus 7 over 1, which would be plus or minus 7, and plus or minus 7 over 2, which would be plus or minus 7/2 or 3.5. So we can't forget about the stuff we learned earlier. We may need to use it again later, out of the blue. So now we can plug in some of these values into our function to see which one of those might give us 0, and we can reduce it. I would start with something small, like maybe positive 1. Since we already have some negatives in there, let's try f of 1. We get 2 times 1 cubed minus 5 times 1 squared plus 10 times 1 minus 7. And that does, in fact, give us a 0. So we know that 1 is an x-intercept, a 0 this polynomial. So let's divide by that 1 using our synthetic division and all of our coefficients from our original, 2, -5, 10, and -7. Bring down the 2, multiply by the 1. We have the 2 combine, and we get a -3. Times that 1 is -3. Combine, 7 times 1 is 7. Bring up the 7, combine, and we get 0. And remember, we started with a cubic, x cubed, so we go down 1 degree, and we get 2x squared minus 3x plus 7 as our other factor. Well, we were hoping that this trinomial here would be factorable, but it's not. We multiplied 2 times 7, we'd get 14, no factors of 14 that add to a -3. But we can use the quadratic formula. So remember, x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So when we plug this in, we get the opposite of -3, which is 3, plus or minus the square root of our -3 squared, which is 9, minus 4 times our 2 times our 7, all over 2 times our 2. Well, if we're to reduce inside that square root, we would end up with 3 plus or minus the square root of -47 divided by 4. This is not a real number. Therefore, those little 3 dots, not an x-intercept or 0. So we did all that work. We had to find out, but there's only one x-intercept, and that is x equals 1. So we can go to our number line. We're going to plug in 1. And remember, our 1 is where it equals 0, but we don't want where it equals 0 this time. We only want where it's negative. We don't have the or equals to bar. So the 1 will not be included, but it does split our graph into 2 intervals. Let's do a test point to the left. I would choose 0, love zeros. And a test point to the right, possibly 100. So if we plug in f of 0, we would end up with, in the original, a 0 minus a 0 plus a 0 minus 7. So the left side would be negative. And on the right-hand side, we have a positive 100. So the sign of f of 100 would be 2 times 100 cubed minus 5 times 100 squared plus 10 times 100 minus 7. Well, really, this first binomial there is really going to take over, and we're going to end up with a positive. So since we're only looking for values that would give us a y value that's negative, we are only looking for the left side, below -1. So our solution is from parentheses negative infinity to the left, all the way to 1 parentheses, since 1 is not included. When we are solving polynomial inequalities, we could also use our knowledge of end behavior and what the graphs look like. For example, in this top one, we know it's a quadratic. Our leading coefficient of 2 here is positive, so we know it opens up. So if we found 2 zeros, it has to be positive, negative, and positive. But trust me, there's a reason I showed you the number line. It's going to be here in a minute. But you can always double check since you know what the graph should look like. Same thing for problem B. We have a cubic this time with a positive a, which means our function is going to go like this. And if there is only one x-intercept, we know it's going to go from negative to the left to positive to the right, which is what we got here in our number line. So that's a nice way to check.